Rob's Fix-It Shop. Today on the bench I've got an Acoustic Model 470. It's a guitar amp from the early 70s and heavier, pretty damn heavy. And I've had this for a while. This is the amp that got me interested in repairing amplifiers. And my son bought it at a garage sale, and we turned it on and it ran for a few minutes, made a bunch of weird noises, and then never ran again. And it took me quite a while to figure out all the stuff that was wrong with it, because there was a lot wrong with it. And but while I was doing that, I learned a lot about amplifiers. And so what I'm doing today is my son, who's the guitarist, says that it's not working again. So I'm just going to open it up, but while I open it up, I hope to talk about a little bit about some of the other things I saw in this amplifier and the stuff I learned when I was putting it all together. So it's on. There's A and a B channel, right? So we're on A channel. I've got the distortion turned off and the reverb is turned off. All our we're in the mid-range here, and so let's turn it up. That's pretty funky. So we're not getting much output. Yeah, there's hardly anything coming out. Make sure I've got output coming out. And so let's check the B channel. B channel's messed up too. That's interesting. Most of the problems I had with it before were with the main amp, and well, I had problems with both the main amp and the preamp. The preamp had a bunch of FETs that were out, and the FETs were to switch on different features, and a lot of those were bad, and I replaced those, and that got stuff like this working, or the distortion was messed up. I'm going to set up my scope so that it triggers on. It's like there's all kinds of noise on there, right? And so it's not triggering properly. So I'm going to bring the signal in directly. So a couple of things. I've got a current limiter on it, so it's not going to go up too high. If I turn it up to, see, that almost looks like, I don't know what's going on with that signal jumping all over. It does have some crossover distortion. I know it's kind of hard to see. If I lower it down, you see right there. Huh. Well, I don't know what it is. So here it is. It's got your reverb tank, full-length reverb tank. I had to replace that. That was missing when I got the amp. Look at this power capacitor here. Unbelievable. So this is 150 watts, but the amplifier goes from 0 to 90 volts, and then it uses a coupling capacitor to drive the speakers. And I replaced all the capacitors in here, but I did not replace that one. And maybe I should have, I suppose. That would have made, I mean, that's the final link in the sound. But yeah, the transformer is just massive. So yeah, I mean, there's not too much to the amp. I mean, what was happening when I had it before is that this transistor, no, these transistors here, this one here, and this one here would burn out. And this is the driver. These are the two driver transistors. And so your signal path kind of comes in through here and comes down here. And here's a differential pair. And then comes to this driver. And this driver drives these two guys. And then these two guys drive the big power transistors, right? And this guy was just cooking every time. So I bought a whole bunch of these, and then I ended up burning them all out because I wasn't smart enough to have a current limiting bulb. But as soon as I got the current limiting bulb, then I could see that something was going on. But what was happening is that there was actually, and it took me forever to figure this out, but the on these big power transistors, one of them had a bad connection on it. And that was cooking everything. Took me forever to find, right? And so I think if we come in right here, this is where the signal's coming into the amplifier, right in here. And this here, this is a power supply. That's the other thing that was bad with this amplifier. So these are there's two of these boards that manage the, you know, the preamp and all the effects. And this is, there's somewhere in here, there's a Zener diode. I think it's this one right here. And that one was off, and so you're getting way too much voltage going to here. I think it's supposed to be 17 volts, and it was a lot higher, and I'm wondering if that burned out all the FETs in here, because I had to replace quite a few of those FETs. But I had everything working great, so I don't know what's going on. So let's just take the scope and see if our signal coming in is good. And I think I can just hook it up right here. So here's the power supply I was talking about. You know, the 92 volts comes into here, kind of runs through here, and this transistor is kind of controlled by this Zener diode right here, and then that puts a 34 volt output. Look at our signal path. It's kind of coming in through here, right? It goes to a 44.7K. And then I think this stuff here, I think that's to limit the amount of current, right? Because I think if the current or the input signal, it's meant to clip the input signal. And then we go through this 0.47, and then we've got this weird thing here, this symmetry. I don't quite get that, but I never did, right? But then the signal comes in over here through this 2.2K and then comes into this differential pair here. And the differential pair, you can see if you look over here, that's coming down the main rail of the output and then comes up through here and then through 100K and then comes into this differential pair. And so this is your feedback line here. And so that then once you come out of this differential pair, you come to this driver, right? This driver right here. And then that driver actually, how does that work now? So that driver then drives this transistor, and then that drives these three. This is the upper or lower, this is the lower end of the wave, and then you see it drops. I'm not exactly sure how this works here, but I think this is running the other side of the push-pull, and that comes through. Oh yeah, that comes through here. This is another driver transistor. This is the one that was burning out before. Nope, comes through here, and then drives those. One of the ones drive the other two big ones, and the big ones here and here then are doing the push-pull through here. And yeah, so let's take a look at that. So let's find this guy right here and see what kind of a signal we have coming in. Okay, so let's take a look. I've got, this is my signal coming in from my signal generator, and I just got this scope channel just connected right to it. And so these here, this one here I think is our 4.7K, and here you see kind of the current limiters on it. And so I think if we go right here, we should see our input signal. Yeah, so something's very wrong. Look at how much current we're using there, and I'm hardly even up. I mean, yeah, so something's messed up. Okay, so I disconnected the lead here that feeds the power amp with everything from the preamp. And let's see, do I have everything hooked up? Yep, so if I turn it up, wow, that looks pretty good actually. It looks like we've got a pretty good wave. I don't know, it looks a little funny, but it does seem very consistent, and it does seem like at the top it's about 300, peak to peak it's about 300 millivolts. It seems a little low. Let's go to B. Yeah, channel B looks like the same thing. I mean, it gets distortion-y around 300 millivolts, but that's, I guess that's okay. I don't know. But I mean, it's interesting that it seems like it's probably the power amp then, right? Because if that signal's coming out all right. So now let's try putting the signal generator directly into the amplifier. Okay, so I'm coming in with about 100 millivolts, and it's putting out, it's jumping all over the place. I mean, it's using a lot of current, and so I'm just gonna, something's jumpy on it. So, okay, so I forgot, I messed up, I didn't film this, but so I was actually, like, when I was tapping on the symmetry potentiometer, and I don't know what the hell symmetry means, but see, look how it screws up that signal coming out of the differential pair. Go like that, and then it's cranked all the way over. Right, and then I adjusted the bias too, because the bias, you could see, let me turn it down. You could see the crossover distortion. There, see the crossover distortion? And then if I bring it there, it's gone. But now it doesn't seem to be having the problem. So here's we're the 170045 build, and if you look at the newer build, which is the 17051, they get rid of this, right? And that whole symmetry potentiometer, and they change a couple of resistors. I go back here. Where are we looking? Oh. So they just jumper. So they change this resistor here and this resistor here, and then this is the wiper. They jumper across here and jumper across there. So that's what I'm going to do. I'm just going to take that thing out as long as it's being problematic. Kind of nice with this one-sided circuit board. You can see everything, but here you have the 92 volts going to this. Let me see what we got. So this is our 408, and we need to go from 15K to 14K here. And we come through this diode into here. We need to pull this, and then right here, this is 403. We need to go from 47K to 100K. That shouldn't be too hard. All right, so I pulled out the potentiometer and did the changes I recommended. Changed 403 to from 47K to 100K. Changed 408 from 15K to 18K, and just took that potentiometer and just jumpered across all three of them. So I'm going to plug it back into the current limiter. All right, well, let's switch it on. Well, it doesn't look any worse. Yeah. Looks like the bias is still off. Let me see where I'm at with this. Turn this way down. That's funny, that bias is as far as it will go. Let's try cranking it up a little bit. Okay, I just had to take it off my dim bulb tester. Okay, so that's about 150 millivolts peak to peak. 18 watts. But that signal gets really distorted. This gets distorted. So that's 50 watts, right? I mean, it's still looking pretty good, but I don't know what's going on there. That's 24. So we're really distorted at that point. I know this used to work before. So I don't know what's causing that waveform. I'm going to have to do some tests and see if I can figure out what's going on. It seems kind of funky how the signal coming into that first driver transistor is so screwed up. I wonder about these guys here, right? Yeah, I think it's worth swapping those out with something else and seeing if it's those transistors that are being bad, because yeah, you wouldn't, there's really nothing else in front of this that would notch that like that. Okay, so I pulled out those two PNP transistors, and one of the reasons I'm suspicious of them is because when I was first working on this and I didn't know anything, I know slightly more now, I thought I would just buy exact replacements, right? So of course I go on eBay and try to find exactly the same transistor, right? And so you end up with new old stock transistors, and yeah. And I didn't realize at the time I could just replace it with something that was modern, but Okay, so got an HFE of 225, right? PNP. And so then, oops, let's test the other one. And PNP HFE at 307. So I'm going to look up this transistor and see if I can find a suitable replacement. I mean, they look like they're fine. I don't know. But I guess it's kind of the first thing to try. Okay, so well, this thing took a lot of debugging and farting around. And I went down a bunch of rabbit holes and chased some stuff I didn't need to. And I learned some stuff out of it, but it really doesn't make a very compelling video. And so I will tell you what I ended up doing is I was saying, I was getting a distorted signal. I wasn't getting very much output. I replaced these two transistors in a differential pair. And then I replaced these two transistors here that are part of the bias circuit, right? And then I took out that potentiometer here that was part of the bias circuit, and I put in this one. And another thing I found is there was a resistor going between this driver here and up to the one of the big transistors on the back. One of the big transistors. This resistor right here, that was it's supposed to be 100 ohms, and it was 50. And I think that would kind of unbalance the two channels. But so I replaced that. I replaced a bunch of these hundreds. Seemed kind of messed up, and so I replaced those. And so after doing all that, it really seems to be working pretty nice now. So here are the transistors I used. KSC 1845 FTA and their pair KSA 992. And so I've just got a bunch of those around for small signal work, and yeah, they work pretty good. Okay, so let me show you what that bass button is doing. So if we come over here and we look at let's flip the amplifier on, and we come over to our signal analyzer. Hit start. What we're looking at here is a logarithmic scale from 20 hertz to, let me make sure of that. Start, 0, stop. Okay, that's close, right? So what we're looking at is a logarithmic scale from 0 hertz to, there is, we can look right here what the hertz are. 100 hertz, and we're flat up until we get to about 1K. And then we're starting to drop off, but really this is not very much. This is decibels, so it's not really very much of a drop off here. But then as we start going up in signal, there's 2K. Now we're starting to have a real difference. 15 dB. We're dropping down 30 dB from here down to here. So that's on bass. So I'm going to switch it over to lead. And with our lead then, if we're looking, let's scroll all the way back to at about 30 hertz, we do have some signal, and it's not too big a difference. But by the time we get to 100 hertz, we're very flat all the way across, right? Very flat. Yeah, looks good. And again, I'm not going through the front preamp. I'm going straight to the amplifier itself. So let's I think I'm gonna hook it up to the preamp again, And then let's look at the power and distortion. Or first let's look at setting the bias. Okay, so let's just look at, for those who aren't as familiar with how these amplifiers work, is that so if you've got a sine wave like this, right, coming in, you've got one bank of transistors on this amp, at least, or this is a type AB amp, right? You've got one set of transistors. Let's put our 0 volts here, right? So this bank of transistors here, this is working on the top part of the signal, right? And this bank of transistors is working on the bottom half. And then they take that output and they mix it together, and then what you should get is this, right? Very nice. But if the amount that's going into these transistors and what you've got going into these transistors isn't matched, what you're going to get is kind of a misalignment, right? And this amplifier has a potentiometer for adjusting that amount that goes to one bank or the other bank. And it looks like in the newer version, that adjustment was made by a transistor circuit, but this older one has a potentiometer. I took that potentiometer out and I put in a little bit of a nicer one, but I'll just show how to adjust that. And the thing that's bad about this crossover here is that if it's almost like a little bit like a square wave, and square wave are made of third order harmonics, and third order harmonics sound harsh, so you really want to fix this, and you want to get it so it just gets right, but it doesn't do overkill either, because if you go too far in your adjustment, it can make the amp work harder. So let's take a look at that. So here's the potentiometer I put it in, and this one, which is pretty crusty looking, and really why I had to get into this thing at all is because the other potentiometer, which I took out, was pretty crusty too. And so the other thing is that it was all the way to one side, and so it was all cranked all the way to one direction. So I put in a little bit of a larger one so that we could get the do a better job of getting it matched up. And so here, if we look at our scope, right, we can see that that little edge where, see that edge? We can see that edge where those two banks of transistors aren't matched up, right? And so what we're going to do is we're going to adjust that there. The other thing to look at is if we look over at, here I'm looking at the frequency analysis. If we look at and this is a logarithmic scale, so this is a lot and this is not very much, but you can see that we've got about 4% harmonic distortion down here, and we've got, oops, I'm just averaging it because it jumps around otherwise, but we can see that this is our 1 kilohertz, right? That's our second order harmonic. And that's 3000, that's our third order harmonic. These second order harmonics tend to sound harmonic, right? But the third order ones sound harsh And so we want to get rid of those. And so I'm going to come back over here and look at the scope again. Whoops, that's not my scope. Look at my scope again, and I'm going to turn that potentiometer. Most amplifiers will have kind of a setup that shows you how to adjust this by setting the current across those output resistors, but this one doesn't, so I'm just going to do it by hand or by eye. And let's see here. Okay, got my screwdriver on here. And you see I'm starting to kind of match up, right? And I'm going to put them back. And then I'm going to go over to the distortion. And you can watch the distortion as well. That as I bring those two together, the distortion, we should see those third order harmonics. Oh, hang on. So there's the live view. And you can see as I start to bring the bias into line, you start to see those third order harmonics really disappear, right? And so there our amp has a harmonic distortion of about 0.9%. And this isn't that much volume. We can take a look at it when we crank the volume, but yeah. So I consider that to be pretty cool. Yeah, and there we got it all the way down to 0.2%. And it doesn't seem to be changing too much more. So that's great. That's that shows you that the feedback's all working, and yeah. There's our wave all nice and clean. Okay, so then now let's take and so this thing is a beast, right? But it's a lot. And so we're gonna put it into my dummy load, and I'm gonna reconnect the preamp, and we'll put it through some stuff. Okay, so I've got it plugged into the wall, which is always an act of faith, but I've been running it for a while, and I've got a let's see if I can show you. A giant 8-ohm dummy load, right? Big porcelain thing, right? And I have that, and I have the amplifier hooked up into that. So let's take a look at what we've got here. So I'm going to flip it on. And if we look at our scope, we can see our peak to peak is, let's see if we can turn up a little more. So our peak to peak is about 24 volts per channel. And so if we take 24 squared, divide it by 8. So it's putting it out about 72 watts, which is kind of low. But the main power rail is supposed to be 92. And it's actually much lower than that. I think it's 86. Let me just check here. Yeah, so the main power rail is 81 volts, right? Which is quite a bit less. I mean, that's enough to make the difference. But so I don't know what's causing that. What's causing it to be lower? It could be this this capacitor here that's on the power supply. I mean, it's giant, right? But if that's shorting a little bit, I tested it. It seemed okay, but I don't know. If it were shorting a little bit, I guess that could bring the voltage down. But yeah, we have nice clean power coming out of it. And so yeah, so let's back up. Like I say, that's up there. And so first let's look at, can we look at so that's our dummy load there. About 90. Should be heating up. No, it's more than that. So this is my dummy load. Yeah, so that's 220 degrees. It's cooking, right? But let's look at these power transistors. See, they're all looking really nice, right? This here, this is cooling down. I had it running, so I think this is still cooling down a little bit. But I think you'll see these come up. Yeah, and they were coming up to about 110 or so. But I don't know, that doesn't seem that bad to me. And the transistors on the main board, they don't seem to be getting that hot at all. Also, if we go over here and we look at our analyzer. So we're going through the preamp now, and so we're going through the preamp now, and you know, we are getting some of these harmonics, but we're getting less than 1%, less than 1% distortion on there. Which, I don't know, for an old guitar amp like that, I think that's probably pretty good. I mean, given that there's buttons on it to create distortion. So one of my casualties here is this doesn't seem to work. It's not switching between the channels anymore. And so, and I know that worked. I looked at the beginning of the video. It's working. Let's take a look at that circuit. Okay, so here's our schematic for the channel switching. And really what you've got is you've got this, this JFET here, right here. And it's kind of pulled high normally, but then the AB switch grounds it. So when it's grounding, then you'll get signal passing through like this, right? Actually, this will turn on the light bulb, but it will also put signal like this, and it will shut off this JFET, right? Which will disable the other light. So only one of these is on at a time, but and it depends on whether this signal is high or low. It's 0.3 volts for A, 33 volts for B, and then it actually has these FETs here, which are switching. I think you have your signal coming in, your A signal coming in like this, and your B signal coming in like this, and then they kind of exit out like that. Kind of a mess, but so really, first thing we want to check is we want to check this guy here to see if it's 0.6 or 0 volts. And we should be able to find it by tracing this yellow wire. Okay, so here's our yellow wire right here. And I think one of them goes to the switch and one of them goes to a foot pedal. And here's the red wire. I'm going through the current limiter And so I don't have the 92 volts. I got 65. And so then it's supposed to be either 0.6 or 0 volts on the yellow. And we've actually got 64 volts, which seems funny. And so it's properly grounding, but it's really flying high. Coming down here, right? Now this says 92, but we're going through the current limiter. And so this was like 72 volts or whatever it was. And we're seeing 72 volts here, right? And so what that's telling me is that normally we should have a 0.6 volt drop across this MPS A06 is the transistor to here, right? So that should be dragging that, because that's such a big resistor there, that should be dragging that down, but also turning on the transistor, right? And the transistor is then going to turn off this guy, but it's also going to power the light, the A light bulb, right? So I think this guy is bad, right? We should see current flowing through here, and we're not. So I'm going to replace that transistor and see if that helps our problem. This guy should do the trick. All right, so here's the news. Bad or damaged part. All right, well, it's in. Let's give it a try. Okay, we're on B. Hey, look at that. Pretty sweet. And that transistor I put in there is 120 volts, where the one that was in there before, that MPS A06 or whatever it was, that seemed to have a lower voltage rating, although they both have the same current rating. Well, that's great. And then so the only thing we have left on this guy, we're going to replace this and see if that brings the voltage up in the power supply. And we're going to replace this with a newer capacitor since we replaced everything else. Then we're done. Then I'm going to get my son in here, see if he can give us a demo. So the voltage seems a little bit low on the main rail. And so I thought, I'm going to pull this big monster capacitor out of here. I got another one that's still giant. Cost me like $8. But I'm going to pull this guy out of here. But first I want to check what the voltage is with it in. And my theory is that this guy is shorting a little bit. And that's just pulling the voltage down, eating up current. And then I've got this guy. So this has got this clamp here. And so I made this. And I'm going to put this in here. Put that in there. And I think it's going to be great. But let's check the voltage first before we start. So let's turn it on. We got about 86 volts. What do we got here? Okay, well, that's not... I mean, the schematic is showing 92. But anyway, so let's pull this out and see if it makes any difference whatsoever. Yeah, quite the monstrosity. Okay, so that just fits right in there. I'm going to have to clear this out a little bit because this doesn't fit great. Okay, so that just fits in there, and I just drew this out in SketchUp and did it on my 3D printer, and I just take the outside measurement and the inside measurement, take 2 circles and cut the center out, and then I just added circles around here to kind of give it kind of a groovy look. But yeah, let's tighten this down. Yep, and that's not going anywhere, right? And it's not in there too tight either. So I'm just going to solder these guys onto here. And yeah. All right, well, I think that looks pretty nice. I went in there pretty good. And I was able to have the wires come in like that and out like that. So let's switch it on. I've got it on the dim bulb. Whoops. I unplugged it. It makes me nervous working on that giant capacitor. Charges up nice. Okay, so now I'm going to take it off the dim bulb and put it on the mains. All right, now let's check the voltage. 86? Well, that's about what it was before, wasn't it? I don't know why, but Georgia came down to say hi. Hi, Georgia. What you doing? What you doing, huh? Oh, good girl. Good girl. Oh. Okay, run away. All right, so well, one thing I found, so now that I've got things working better, I got the transistors all in there and they're working great, is that I had also kind of upgraded the section of the circuit that had that symmetry potentiometer in it. And something I'm looking at here, if I turn on the amp and crank it up, right, you see how here we're clipping quite a bit earlier than this guy's clipping, right? And I wonder if that's what that symmetry, I'm sure that's what symmetry was doing, right? And I wonder if these transistors are just enough different that this circuit is not working. So I'm going to go back to the original circuit, put a potentiometer in there and see if I can adjust where that's happening. Because what's happening is the center of the amplifier, the 0 point of the amplifier, is really the full rail voltage, which is 86 here, half of that, right? And so that plus a little bit, but and so that's off, and if that's off, then you're going to get clipping a little bit early, and then your full output is kind of diminished, right? And so yeah, so I'm going to put that circuit back the way it was, and I'm going to put that potentiometer in there, and let's see if we can adjust that. Okay, so we got our 2 resistors, original resistors, soldered back in, and I put this little potentiometer right here. What is it, 100K? No, 10K. And I kind of redrew the circuit here, and so it's almost like this was the circuit for the newer model, and you just have a voltage divider here right in the center from ground, and so you've got 92 here, you've got ground here, voltage divider, and here you've just got the ability to kind of move within that voltage divider, and I think that's why these potentiometers were, or these resistors were different. But I put it back to original, but I put a different potentiometer in it. So let's take a look at how we look. So we got some of our crossover distortion back, right? But so we'll have to look at that again. But we do have a wave up to, then our dim bulb starts going off. So I'm going to plug it into the regular power. Let's see what we've got. And then our clipping is balanced right in between the two. I didn't even have to adjust it at all. So we can look at what that symmetry pot is doing. If we crank it way up, right? And so there we're seeing the clipping there. Then if we move the symmetry pot, we can see the bottom disappearing. We're kind of moving that wave kind of up and down like that. And we want it centered just right between. Right, that looks good. So then if I crank it up, we're clipping on both the top and the bottom. Okay, so now I know what symmetry does. And what do we got there? About 24.3 volts RMS. So about 73 watts. We added about 3 watts by putting that pot back in. Not that big a deal, but it is nice to have it running right. Well, that's it for this repair video on this really cool Acoustic 470 amp from the 70s. It's a pretty cool amp. It's built like a tank, and it's got a lot of features. It was very popular back in the 70s, and so I brought my son David. He's a guitarist. He's going to walk us through with his bass and then a little bit of the guitar so you can see what this amp can do.
All right, so for the most part, this thing has like a couple different places to adjust EQ. So like everything right now is flat except for it's set to the bass setting, which just makes it gives it like a low pass. Get that high end out so that it would sound like. It's just like a pretty standard bass sound. If we're taking the mids out a little bit, we can get a sound that's a little bit more clear. So then we start to get, if we take the mids out, we can hear it gets a little bit brighter. For anything that's like, I guess this would only be like really good for like, this isn't the bass for it, but like jazz stuff where you get like that, you can get a very like low round sound. The bass feature in general isn't great for like rock stuff. So like this is, we're gonna turn the highs up a little bit, and the lows. Let's get that like. So like stuff like that. It still doesn't really sound like our stadium rock bass. But if you turn to the not bass setting, you can get that. Get that to be a little bit brighter for bass. That's optimal, I feel like. Alright, let's do guitar. So with guitar, one thing about this amp is that it's got a lot of bite. So when you're playing just normal chords, the treble's not set. Here, I'll put it back to normal. Actually, no, I'm going to take some of the bit out. Yeah, having it on normal, or just like everything flat. There's still just like a little bit of bite and a little bit of that ring that comes over. But if you do, what happens with that is that distortion here. Oh, is the distortion on? It becomes very bitey, very fast. Where you can still get notes to. What's nice about this distortion is that you can still get those like those weird chords to ring out, like that kind of stuff. But it's still just so high and deep. To where if you tried to level it out a little bit, and these are still normal. The best you could do is like just still pretty bitey. And I noticed that there's also like this, whenever you're doing lead stuff, it's hard to get the rhythm to sound good, and then also the lead without it just breaking your ears at certain levels. Because right now it's not being driven super hard. Yeah, it's not being pushed super hard, like it's not super loud, and it's still getting that kind of super in-your-face tone. Yeah, I guess I don't have that much more to say about it.
Let's turn the...
Oh, try that, yeah. Yeah, sweet.
All right, cool. So that's it for my video on this Acoustic 470. I just find it a really interesting amp. So just to kind of recap what I did is that a lot of the problems came from that symmetry potentiometer. So when I pulled that, things got a lot better. I could see then that it still wasn't, the waveforms are just kind of strange. I really didn't get a handle on it, but I replaced those transistors in the differential pair and then the transistors in the bias circuit, and then it started working great. And so I also found a couple of resistors that were out of tolerance. The potentiometer, so I replaced both the potentiometer for the symmetry and the bias, and put the screw type in, which are much easier to adjust and are all enclosed, so they should last pretty good. And so I think it's working pretty good now. One thing to kind of remember with this is that to get that traditional guitar amp sound, it's a flat. I mean, the frequency response on it, as we saw, is pretty flat, right? So I think you're going to want your equalizer set more like this to kind of pull that mid-range down. And my son was saying that too. And then use the treble, mid, and bass here to kind of adjust for your particular sound. And I didn't demo the tremolo on here, or the reverb on here, because right before I was going to demo it, it quit working. So I think I'm going to fix that in another video. It should be kind of interesting. But if you liked it, I mean, it was a long video, but if you liked it, please hit like and subscribe, and thanks for joining me.